I'm Raj. I'm responsible for product management and product marketing at Inventec. And to continue this session, I'll talk about network telemetry and how we are using it on our products. So Inventec is manufacturing SD and Ethernet switches and SmartNICs, and we have contributed a couple of switches to OCP. So we are very much part of OCP, and we believe in this reimagining of this hardware for cost reasons, for choice, and for customizations that customers are getting. And now what I feel is that OCP is turning out to be a global community. I have visited different countries, and everywhere I'm seeing that OCP is making an impact, and there are folks sharing ideas, and I think at this point, standardization as well can be part of OCP, and we have already started that. So we are part of this community, and we are participating in most of the activities here that you can see on the screen. As for example, we are part of Sonic and Psi community. We are part of the ONOS with P4. And also, we are working in the community with ONI-based switches and with Open Daylight as well. And our switches support multiple merchant silicon underneath. So let me delve right into telemetry right here. That if we look at the telemetry on our existing routers and switches, it is quite rudimentary. You can see output from a router here, where it is showing a CLI output of a minor alarm. The red font is showing you that. And then there is a syslog message showing you a major alarm. So it is not giving you more information or detailed information of exactly what is happening, how it is happening, where it is happening. It is just telling you that it will shut down in 4 minutes. And again, based on history, I know that it does not exactly show you where the problem happened. And it will shut down almost 11 to 12 line cards in the chassis. Similar problem on the CPU front, that we are saying that when we use CLI or sampling, that adds to CPU bandwidth, and the CPU processing power increases, and eventually it does not help either. So there are multiple issues here. When we look at the existing mechanisms, the data is quite coarse, and we heard that from other speakers as well. The SNMP polling puts a lot of load on your control CPU. These days, customers are using quite around 5 minutes or so of polling, and sometimes they can reduce it down to 1 minute. And then once you start going lower and lower, you will see that the CPU will eventually hang, or it may just crash. I have talked to many IT admins, and when I talk to them, they still like using CLI scripts, but every change in configuration means there is a small change on the CLI front as well. Folks in the service provider industry use IPFix quite a bit. Folks use 1:1000 of IP flow. So that means in the IPFix, they sample 1 packet for every 1,000 packets. This is fine, but in case you have a very small flow, you will miss it entirely. If you try to sample it more often, then you will not be able to hit the line rate. So this is something that the customers are continuously dealing with. Also, once you extract this data out, to correlate it is extremely difficult. So if you want to correlate the data that you got today versus that of yesterday or a few days back, that is a problem in itself. And as I mentioned, there is no hint or root cause given in some of these things. So we have been working with merchant silicon providers to work on a couple of different schemes. One is this agent-based telemetry, another is the packet-based telemetry. So in this agent-based telemetry, what we are doing is essentially there is a software agent that is loaded on the switch, and it extracts information out from the switch and is sent out to the SDN controller. The most important thing to understand here is that there is a feedback loop. So what we have been trying to do here is that we have been extracting data from, let's say there is a threshold buffer that we are looking at. And once that trigger, once a trigger is there for the threshold buffer, this data is sent to the SDN controller, and it can then reconfigure the switch to completely change the traffic flow for the future flows. So it can kind of reduce the congestion in a given switch on a given link. There are a lot more other use cases here that we have been doing. One is that of black holing traffic, that sometimes the packet keeps on internally recirculating in the switch and in the between the leaf and spine network, and that can be detected as well. And we will, right now we don't have time for demo here, but we'll be able to show the demo if you are interested. Roberto at Barefoot mentioned about the in-band network telemetry. This is another telemetry that we have implemented on our products. So here, if you look at it, at every step of the network, we are adding metadata to the packet. So this is like a hop latency that is added between the header and the payload. And this keeps on adding at every step in the, every hop in the overall network. And just the penultimate node, which is called the sync node, that's where the data is extracted out before the packet is sent to the destination. So this is something that is improving on the telemetry. If you look at it, first there were issues with SNMP because it was a polling model. Then we moved to an agent-based telemetry, which will eventually do push model. And now we are completely removing the control plane and only handling this in the data plane, so there is no load on your routing or your control CPU. So this is something which is eventually going to be used in multiple different merchant silicons. Now, we want to go a little bit further. So once we look at this, we see that the data center SLAs are looking for network delay, they are looking for network jitter, they are talking about packet loss. But if we want to get more information, can we get it? Currently, the way we are looking at this telemetry, we are not getting it. But there are ways where we can add some more information through deep learning. And the reason we can now insert deep learning into networking is because of some of these reasons that I'm mentioning here. Now we have a lot more data available. Also, the compute and the storage has become much cheaper. And the algorithms for neural network have matured quite a bit. If you look at some of the research from NVIDIA, they have been doing 100 hidden layers of neural network. And that is now possible because the GPUs have been very effectively used for matrix multiplications in handling some of these neural networks. So once you use neural networks in some of this, then you can get much more information from this type of telemetry. And most importantly, the SDN is the key part to this. If you look at how the networks are, they are inherently distributed. So if you look at a switch with its own control plane, it has a very limited view. And with the control plane now being decoupled, removed from the underlying switch and centralized, you have a much more holistic view of the network. And that is aiding in getting this additional information. So if you, one of the ways that folks have looked at the getting deep learning onto the networks is using deep reinforcement learning. If you look at deep reinforcement learning, the fundamental difference with any other supervised learning or an unsupervised learning of neural network is that there is no modeling involved. Networks are nonlinear dynamic systems, and here modeling it would only simplify it, and it will make it kind of less complex, but it will not represent the network in its entirety. So using a deep reinforcement learning will be more helpful, since here we interact with the network, which is the environment, and then take an action to essentially get additional feedback, which is the reward, back into this network. So this is, I'm just showing a very simplistic view of this, but essentially it's a time series of steps that needs to be taken, and at every step, more information is available for the policy to be brought closer to the target policy. So as for example, if you want the network to have an optimum delay, network delay, then you can set a policy for that, and then eventually you will reach that target policy over a certain number of iterations. So if we look at our diagram again, we can see that there is a network, a deep learning layer that has been added to this feedback loop, and we can visualize and take the feedback out from the neural network onto the SDN controller. And there was a small experiment that we had done to add a network bias to certain nodes, and then the goal was to optimize for network delay along with some other network parameters. And the training was done, and to achieve, basically, this is where the graph is showing that we were able to train the network. So I believe that with some of this AI that will be omnipresent in 2025, we should be able to make the networks more predictive, and we should be able to do some of the things. I think there was a question on anomaly detection. We should be able to get most of those things on the networks done with the help of some of the new telemetry methods and the deep learning.
All right. Thank you, Raj. Please help me thank Raj. Any questions? Actually, so at this point, we've got about 15 minutes left. We're going to transition just into general questions and discussion, but let's go ahead and start with some questions for Raj.
Could you talk a little bit about results that you have seen from this experimentation, and if this is just in experiment stage, or is this getting towards production deployment, and how soon?
Yeah. So yes, we are very much at the experimental stage at this time. It's a very early stage, and at this time, I think what we have done is just a very small network in which we have tested this. And this will eventually become much better with more data. And the in-band network telemetry with this metadata, once you start adding more and more metadata, see, essentially the basics of what Barefoot and Roberto mentioned is that you can insert anything you want. It's just a metadata, and you can get it from your ASIC. So depending on how you want to optimize your network for, you can get that data, and at every hop in your network, you can then view that metadata. And then this neural network can function offline also, and folks have mentioned about online also. So online will be much more difficult, but at this time, what you can do is you can bring the data in an offline fashion, and then kind of make it learn. And then that configuration settings can be inserted into your active network.
Yeah, so it's a pretty interesting set of hopefully talks for everybody, right? You've got telemetry, you're collecting data. What do you do with the data once you've collected it, right? Are you consuming it as humans? Are you consuming it with heuristics, or are you consuming it with neural networks? And are you doing it in a diagnosis manner? Or are you doing it in a closed feedback manner? So there's a lot of, we start with telemetry and what do you do with it? So we have two questions here. We got one. Let's go to the person who was standing here. And then you can go next. Yeah. Okay.
So you mentioned this experiment. I believe this experiment was conducted only to characterize the configuration, I believe.
Yes.
Is there anything that you guys are doing for troubleshooting, fault tolerance, and those kind of things?
Yes. So as I mentioned, see, this, you can use it for a lot of different things. You can, so we are not currently working on that problem per se, but to look at this fault tolerance. So as I mentioned in the initial slide, that there were some problems with temperature. So in that case, we were not able to get the exact location of where the problem was, what chip was failing. So all of that information can be made available. If you look at this slide, this latest slide, what I'm showing is that a lot of data center information can be extracted out and can be fed into the network. As for example, if you can look at a topology information, if you can get some maintenance data, if you can look at some of the monitoring data, all of that can be fed. This is fairly complex, but as you can put more and more information into the network, the deep learning neural network can help you in figuring out more information.
Yeah, I was just curious to know what other data sources did you tap into? I can see in-band telemetry, but other than that, did you look at other things like syslogs, for example?
Yes.
Did you manage all of them?
Yes. And also sensor data. Basically, there are lots of hardware sensors also, specifically for the temperatures, and also fan controller sensors, and all of that can be added into the data mix.
So you're not talking anything about the control plane, anything from the software side?
So currently we have not added software sensors, but you can very much get the software sensors involved as well.
Okay.
Yes. And,
Take that one offline.
All right, one quick last one. What specific actions your RL agent was carrying out?
So in this so in this RL agent, basically the action was just to select whether you want to take a certain path versus the other path. So in a leaf spine, so I was currently looking at only the internals of the data center, because as yesterday what Facebook is mentioning.
Binary choice, this versus that?
So there were a number of options, yes. Yeah.
So let's broaden it out a little bit here, right? So there's actually, if you were at OFC last week, there were like tons of talks about machine learning at work. So maybe we should have a track like that here at OCP. So I want to generalize it. I see you, just hold on a second. I want to generalize this conversation now to be more about telemetry as a whole, right? What do we as a community want? What are some things that OCP should start doing as a community, or if people are passionate about building systems on top of telemetry, if we're really concerned about getting this inter-switch, inter-ASIC standardization, making sure we really have telemetry well defined as a standard. If you're more interested in higher layer tools, I'd love to hear kind of what folks are interested. First, operators in the room, do you run if you run a network, raise your hand. Okay, awesome. We'll start with you all, kind of like, what would you like from this in-band telemetry and analytics work?
Hi, Kinji from China Mobile. You know, the things, what you print here is very useful, interesting, but the single biggest, the most challenging us is to associate all the data together from a holistic view. It's not like, you know, most difficult issue for us is something happening on one node, but the root cause is far away, not on this particular telemetry data. That is the thing we are looking for right now.
Great, thank you. Other folks that want to talk about, thank you from China Mobile, who has that problem from the operators? Or what are your in-band telemetry, or what problems are you trying to solve with in-band telemetry? Yeah.
So for us to get in-band telemetry today, we have to put taps in a lot of critical areas in the network, and we have to peel that off to a packet aggregation network, and then we have to send that to some tools, which are usually high-dollar tools, to go do that analysis for us. And that's typically a data set that's on an island. So if there's an opportunity to pull that same packet metadata, even knowing most of the packets are going to be encrypted soon, I think that's hugely valuable if that can be standardized and brought to market.
There were a couple of other folks who were operators I saw raise their hand over kind of in this area. So if you want to chime in that's often good fodder for the rest of the folks to chime in with what solutions we're building. So anyone else from the operator community want to talk about in-band telemetry? Otherwise, we've got a few folks who want to chime in on some of those points from China Mobile and from you. Go ahead.
Yeah, hi. I think yesterday's keynote, Andy mentioned about how the north-south traffic hasn't gone up by much, but the east-west traffic has gone through the roof. With this telemetry and metadata, and then it's going to aggravate that east-west traffic, right? So how do we achieve building intent-based deep learning without drastically increasing the east-west traffic? Has it been thought of? And how do you ensure that telemetry traffic is metered or controlled?
Yeah, so
Good question for everybody.
I can touch point, and if you guys want to chime in as well. It's so on China Mobile, I think, great question, great point. So I think one of the advantage of in-band network telemetry is the fact that you can actually, as the packet goes through this journey, it may start from an application or from another part of the network. So that application may be misbehaving and generating too much traffic, and so some other place in the network is experiencing congestion right now. I'm just making an example. So the fact that now you have this history of the packet across the network allows you at that point where the anomaly is detected to reconstruct the full history, where this specific traffic is coming from, what is the source of that packet, what was the path of that packet. Is it like maybe because I'm actually, my network is not load balanced properly? So the fact that INT built that correlation into the packet itself, as metadata, allows you actually to find this kind. And we, doing our initial POCs and production trials with INT, we found this, unexpected findings from customers saying we're able to root cause problems that they never thought they had before, right? And the ability, for example, to do congestion analysis, see, in the queue what packets were part of that congestion, allows you to detect if an application is misbehaving. Detecting the path allows you to detect if there was an imbalance in your network. So there are that is INT, I think, helps a little bit there. On the, I think, packet broker use case, yes, we hear this customers saying, that's the way we monitor networks today, and these are great tools. I think, yes, one of the disadvantages here is that you have to create a parallel network that is your monitoring network. I think what INT provides on top of packet brokers, which are different use cases, I think, but it's like the visibility inside the switch. And with packet broker, you can see the packet on the wire. With INT, these switches and routers know everything about the packet because they forward the packet, they see the packet, they take decisions. So if you can actually take the relevant information out of it, then you can really go to the bottom of these problems. Yeah.
You want to weigh in?
Yeah. So I think that the first step is to do as much measurement as you can. And IOM and INT are a good first step because you get a lot of information, not only about a certain place in the network, but about the entire path of the packet. But that's just the first step. The second step is you get a lot of telemetry information. Now you need to filter that information. You need to decide which information to export. And that's the second challenge. And finally, the third challenge is how you process that information. And I believe that's the biggest challenge and probably needs the most work at this point because we're just at the beginning. And I understand why that's a big issue because once you have so much data, you need to somehow process it and make sense of it.
And one thing that I have not covered in this is for processing, you need end-to-end information. So for customers, they need all the way information up to the application. So we are talking about the lower layers, but eventually it has to be tied to the application as to what is causing the application to slow down and why is it behaving that way. So some of the big networking vendors are working towards it, but this is something that the open community needs to look at as well.
I just want to make an answer to Sugan's question, right? So on the east to west, I agree. That was one of the lessons learned from when I said, the initial trials we did with some customers, the ability to select what applications you want to instrument, the ability to select what metadata goes in, and tailor to the specific use case of the customer. Because, I mean, yes, these switches can do 6.5 terabit or more, and don't even say they don't care. But you don't want to generate too much extra bandwidth in your network. So the ability to have this mechanism in place, like watch lists and triggers, and they help mitigate that. And if it's a small price to pay, people like customers are going to go and pay that price. In exchange, they get visibility and they get a lot of troubleshooting, ability to troubleshoot problems, avoid problems. I think the closed loop use case is a great use case that we are seeing, that goes back. If you have real-time information from the network, you can react and you can do certain things. So, if you have the right trade-off, I think it's always, a trade-off. But if you can be very selective on the traffic analysis and telemetry, then it's a right price to pay. Yeah.
So please help me thank all the speakers again. We're at the end of time. Just a quick question then. Okay, so.
So is there any thoughts given to what data ought to be consumed on the SOC itself, and it doesn't even deserve to be kicked out of the SOC all the way up to some network server to do some analytics? Because a lot of the problems are very local. So if you can actually prevent the SOC from getting into some sort of a failure case, you don't need to actually ship all of that data out.
Yep.
Yeah, I think the point there was like, you've got compute at different layers, right? You can diagnose stuff locally, even possibly on the NIC, some on the system, and then some data you pop up. But the more you pop up to a central place, then the harder it is to then figure out the correlation end to end, because now you're kind of bringing together different pieces. So that's generally the problem I know when we do analytics and remediation at Facebook. How do you kind of unify across and then tag information and then sync timestamps, sync everything else? How do you know that the packet over here was part of the same application or the same container as the packet over there? It's a challenge. So please help me thank the speakers. I'm sorry I have to cut it off here, but just from an official standpoint, thank you to our three speakers. Thank you all for participating in the workshop. This is the end of the workshops. We are certainly open. We're going to post something to the list, Open Compute Networking list. We would love feedback about how you like the format this year, if there's stuff that you would continue for us to do or stuff we could get better at for next year, and any other feedback, not even just for next year, but for continuing workshops. Thank you.